Welcome to Intermediate Algebra. I'm Professor Toner. I'll be your tour guide for this semester's course. And what I'd like to do here is start off in Chapter R with just some of the basics. I know that this may seem like review material to you, but it's very important that you do understand these things inside and out. We begin with definitions of a few different types of numbers, beginning with the natural numbers. Sometimes the natural numbers are considered to be the counting numbers because they're the numbers you can count on your fingers with. And so the set of numbers beginning with 1, 2, 3, etc. are the natural numbers. The whole numbers are very much like the natural numbers, except that they include the number 0 in that set. Now what I like to think of is the 0 has a whole, H-O-L-E, in the center of it, and that's what reminds me that the whole numbers include 0. Integers are basically all the whole numbers, but include the negative numbers also. So I'm going to start at negative infinity and then go up through the negative numbers through 0 and on to the positive numbers that way. Okay, so those are three main types of numbers that are easy to write out in set notation. Now, when we move on to rational numbers, those are any numbers which can be expressed as the fraction of two numbers. Okay, I want you to equate the word rational with fractions because the two words go hand in hand in mathematics. When you hear of rational expressions, we're talking about fractional expressions. Not only fractions, but numbers that are repeating decimals also fall into the rational number category. Now let's talk about why we cannot have a denominator of 0. And this may be kind of a basic definition, but it's a key point throughout this course. Let's pretend we had this picture drawn here with 4 squares, one of which is shaded in. If I shaded in one of the 4, that would be 1 out of 4, and that would be the fraction 1/4. Notice 1 is shaded in out of 4, the number of parts. Now, if I had no parts shaded in, basically I would have 0 parts shaded in out of 4, and that is 0/4, which is 0, which is all perfectly fine. No tricks up the sleeve there. But if I had 4 out of 0 written here, how would I draw a picture? I can't split it up into 0 parts, and I can't shade 4 of them. So in this case, it's 4 over 0, which makes no sense, and we use the word undefined. Undefined is a reserved word in mathematics specifically set aside for division by 0. Now we use it right here within a single fraction, but as you know from previous courses, we also deal with it with slope. Vertical lines have undefined slope because there's no run when you look at the rise and the run. And this is going to be a continuing theme throughout this course and college algebra as well as through calculus. So please don't get these two confused. When the 0 is in the denominator, it's undefined. When the 0 is in the numerator, the fraction is equal to 0. Okay, those are rational numbers that can be written as fractions. Irrational numbers, on the other hand, cannot be written as a fraction or a repeating decimal. Remember how I said a moment ago that repeating decimals are considered to be rational numbers. Now an example of this might be pi. Pi cannot be written as a fraction of two integers, nor can a number like the square root of 7, or if you've learned of this number before, the number e falls into that category. That'll be something we'll be talking about later in the course when we get into logarithms. Now, a real number basically refers to any of the above. Any number that you know of so far is a real number. What isn't real? Well, we'll talk about that later in the course also. If something is not real, it is an imaginary number. And then we have complex numbers also. So real right now basically refers to anything you've heard of in the past.